Hey everyone, we're going to continue our way going through the functional groups and really touching on the last few, starting off with this carbonyl compound side of things and touching on aldehydes and ketones. So I guess we'll begin just kind of going through this. So a carbonyl group is a functional group with a general structure with a carbon double bonded to an oxygen. And so this general carbonyl structure is present for every aldehyde and every ketone that we'll see. So an aldehyde is an organic compound in which the carbon of that carbonyl group is always joined to at least one hydrogen. So you can see on the bottom here for the formula, we've got a single bonded carbon to this hydrogen, and remember where that R just stands for another carbon chain that would run going in this direction over. So we have our carbonyl group present with that double bonded oxygen. Traditionally you'll see it going up or down, but you know that these things can give different orientations, so look for that carbon double bonded oxygen to give you an indication that you're in a carbonyl compounded equation, and then or structural formula, and then after that start to try to identify the rest. Okay, so aldehydes, carbon double bonded oxygen, it's got a carbon chain coming off of it, and then a hydrogen on the other side. So a ketone, on the other hand, is an organic compound in which the carbonyl group, and specifically the carbon, is actually joined with two other carbon chains. So instead of having a hydrogen present on one side, we have just a straight carbon chain. So ketones are kind of in the middle of an equation, if you could picture how these could be drawn out, whereas aldehydes tend to be at the end of these shapes and of these molecules that you'll see. So IUPAC names, and this is kind of how the rest of them are going to run. We'll start off and give you a little bit about them and just kind of go through some of the naming for them and some examples, that sort of thing. So the IUPAC naming system can be used for aldehydes and ketones, the same as the other ones. So first we have to identify the longest hydrocarbon chain that contains that carbonyl group, so specifically from the carbon of the double bonded oxygen. For aldehydes, we're going to replace the E ending with an AL. So instead of saying methane, all of a sudden we're saying methanol. Instead of saying butane, now it's butanol. So for ketones, we replace the E ending and we change it to an ONE. So again, instead of saying methane, we would say methanone, or propane, propanone. So taking off that E ending and replacing it with either an AL or an ONE based on how the carbonyl group is attached specifically with that carbon compound. So on page 738, they have some common ones that are there. You should pause the video, open up the textbook to 738, that section 23.4, and take a look at some of the different types that are there, different common ones. Maybe some of them will maybe seem familiar. And just allow you to kind of familiarize yourself with a little bit of how these things look in terms of their shapes and all names and all that kind of thing. So pause the video, take a look, and come back when you're ready. Alright, so some properties for them. Many aldehydes and ketones, they've been isolated from plants and animals. So their formulas have been extracted and looked at. Many of them in particular have higher molar masses. They have fragrant or really like strong odors and strong smells. Benzaldehyde is one of the simpler aromatic aldehydes that are there, and basically smells like almonds, gives off pleasant almond odors. The most common ketone is propanone, which its common name is acetone, which for those that maybe have used nail polish or smelled nail polish remover, it has a really strong smell to it, and so acetone is in that ketone functional group. So next in this carbonyl chain we have carboxylic acids. They're a compound with a carboxyl group in them, and a carboxyl group consists of a carbonyl group attached to a hydroxyl group. So you can see here that we have our carbon chain, double bonded oxygen, but we have this OH coming off the side. We have this hydroxyl group coming off the side that's here with this carbon this whole carbonyl group being attached to this hydroxyl group. So we have three different types. We've got carbon double bonded oxygen in all three, but one might just have a hydrogen on one side, so that's an aldehyde. One of them might have carbon chains on both sides, those are ketones, and then the other one might have this OH group on one side, and that will tell us that it's a carboxylic acid. So when dissolved in water, acids tend to produce this H+ ion, and basically these ones are no different. So if we were to dissolve them with this H+ ion acting as a catalyst out of this, what we start to see afterward is that we'd have water coming out as well. So in the IUPAC naming system, carboxylic acids are named by replacing the E ending and adding oic. So as we can see here, we've got this double bonded oxygen, we've got an OH group coming off the side, and we would say that this is 2 carbons. So really we would start with ethane. We'd understand that it's a double bonded oxygen, and then try to look to see what's on the other branch of this. In this case it's an OH, so instead of saying ethane, we drop the E and replace it with OIC, so it becomes ethanoic acid. Common household vinegar contains about 5% acetic acid as the common name for ethanoic acid. So in general, most aliphatic carboxylic acids have really unpleasant odors. They're strong scents. The higher the carbon chain becomes, the less volatile and odorless solids will be. So, with that being said, you're ready to try out the Carbonyl compound worksheet. So when you're ready, we'll get that. Ask any questions if you have them, and good luck.